All right, so I'm here at SIGGRAPH 2025 with Nick Schneider. We just finished the special address from NVIDIA where we started to take a look at NuRec, and I'm really excited to have you here with me.
Yeah, thank you, Michael. It's great to be here.
Yeah, it's been a very exciting journey, especially related to SIGGRAPH, because so much of the Radiance field representations have been built at SIGGRAPH, so, and actually kind of like directly related to the world of NVIDIA as well. So just a couple years ago, Instant NGP won Best Paper at SIGGRAPH, and then the year following, then 3D Gaussian Splatting won Best Paper at SIGGRAPH, and now we're here today with the announcement of NuRec. So I was kind of curious if you remember when you first came across any of the Radiance representations. Was it like NeRF, Instant NGP, or?
Yeah, so actually my background is a bit of a different one. Before I joined NVIDIA, I was almost over 10 years in the automotive industry. And then in 2023, I was with Torque Robotics, and I was leading their team that was actually responsible for validating their autonomous driving stack. And at that point of time, we wanted to figure out what do we need to do actually to validate such a complex task, right? Like autonomous driving, especially if you have 40-ton trucks that are driving there. It can be pretty scary, actually. So we were looking into simulation, and a lot of the conventional simulations that were out there, they were actually not good enough because our software that was mostly built on AI was not really behaving the same way as it did in the real world in the simulation. So we had to look into different methods, and this was when we started with a team to build up a neural rendering simulation. We started with NeRFs, actually, but then switched over to Gaussian Splatting because of the speed requirement that we had in our pipeline, and also because we wanted to composite the scene with different Gaussians and different assets. So that was the key development there. Yeah, and so that was actually my first time that I was really developing actively with Gaussian Splatting and NeRF technologies for simulation there.
Yeah, and like you've been mentioning, the technology has been going so fast, where we had 3D Gaussian Splatting come out, and then not too long after we saw a couple papers from NVIDIA where we had 3D Gaussian ray tracing and then 3D Gaussian unscented transform. And so I was kind of curious as well, why something like 3D Gaussian unscented transform provides some even more additional support for simulation-based tasks.
Yeah, that's a good question. So, especially with 3D GRT enabling a lot of other camera models, right? So especially fisheye cameras, as well as rolling shutter, which is so important because we have a variety of sensors in, for example, autonomous vehicles, right? You have them all over, and there are different sensors that need to be supported. And if you want to do that, you have to be very accurate, and 3D Gaussian ray tracing was a key for that. But then it was not fast enough actually to be directly applicable. So we added 3D GUT on top, which made it really as fast as original 3D Gaussian Splatting paper then, yeah. Yeah,
and it's been really awesome to see now you're able to ingest just more different types of lenses, because originally the 3D Gauss, that was with 3D Gaussian Splatting, one of the smaller critiques of it was that you really need that pinhole sensor, and this kind of opens it up to the world of robotics. And so as part of the world of robotics, there recently was added USDZ conversion support to the to 3D GRUT, and so I was kind of wanted to talk through why is that so important for developers out in the world?
Yeah, this has been one of the key things actually to really make 3D Gaussian Splatting experienceable in Omniverse. So now you can really go ahead and train basically any environment that you can imagine. You can take out your cell phone camera, you can record your living room, and bring that real world into simulation, right, with Omniverse. So we can use this USDC output now and render it with Omniverse NuRec, and that allows you to then also use i6 on top, right, where you can place robotic applications and then interact with that real world in simulation. And that is for me a great thing. Imagine, for me being a kid, recording your own living room and placing some R2D2 in there. So that's for me one of the big things now, and it's available for everyone. That's cool.
Yeah, it's amazing that it's very permissibly licensed. I think it's Apache 2,
yes.
So you can use it commercially. And as you were mentioning as well, like I think you can use it for these incredible robotics applications, but you can also create just like very fun experiences too, like you're mentioning. I keep thinking about like creating like a roller coaster tycoon now in like your living room or something like this, where you can create the most amazing content with this and be able to create games that have not really been possible before.
Yeah.
And so when we talk about like some of the companies that have been beginning to use NuRec, I read that Voxel 51 is like one of the early adopters of the technology. And so I kind of wanted to just like talk through a little bit about like how they've found success using NuRec.
So what is important to understand is Voxel 51 is a company that provides data quality tools, right, for customers to build up very good data sets and very high fidelity data sets. And that data is also very important to be an input for the neural reconstruction, right? So the better your input data is, the more high quality also your reconstruction is. And Voxel 51 has been integrating NuRec as part of that, providing tools to assess the quality and fidelity of the input data. And that is really one of the key things that if you want to interact with NuRec, can accelerate your data and your fidelity there.
Yeah, and one of the really cool aspects of NuRec as well is should you have some data that might have some like gaps in it or something, there is a functionality called like Fixer, which I believe is based on like Diffix 3D+. And so I kind of wanted to also chat about that too, that capability.
Yeah, so imagine you are reconstructing a world from scene sensor data, but now all of a sudden you want to drive like 1 or 2 lanes to the left. There's a lot of data that you haven't seen yet in those original drives. So in order to fill those holes, you need some kind of extra information. And Fixer has as a backbone Cosmos, which has seen millions of data. And actually with that, it allows to translate that knowledge from previous recordings into the scene that we have trained with our NuRec reconstructions. And that allows to fill exactly those gaps and enables us to really do this larger shifts and have really great novel view fidelity there.
And then one other portion that I'm kind of curious about is the nrend as well, as part of like NuRec. And so I was wondering if you'd be able to talk a little bit about it.
Yeah, so nrend is a library that is part of NuRec, and it is so important to accelerate reconstruction and rendering. Right? We were talking about bringing the real world into simulation, and we would like to enable basically all kinds of robotics applications with that. And if you think about doing reinforcement learning in such an environment, you want to create like millions of variations, and to do that, you have to be very, very fast in rendering. And nrend is a highly optimized library that really accelerates Gaussian splatting.
That's fascinating. I'm excited to see some of the examples that come out of there. When we talk about like robotics as well, obviously there's a lot of different types of robots, and so we've highlighted self-driving, like autonomous vehicles, as well as say like humanoid robots. But I'm also curious, like where do you kind of see some of these other forms of robotics starting to really benefit from representations like Gaussian splatting?
Yeah. So. Actually, I do think that in the future, everything that moves should be autonomous. And to enable that, you have to train your agents in some kind of a simulation environment, right? So I really do think that we should think about how to get the real world for all different kinds of applications and industries into simulation, and thinking about that will enable a lot of future applications.
And so as part of that like enablement too, one of the topics that's been very prevalent lately has been standardization, and how we can start to move into a world with like Gaussian splatting that is standardized. I'm kind of like curious because it feels like it's hard to judge when something like that's moving so quickly should be standardized, and I'm kind of curious here.
Yeah, that's a good observation. So I do think there's still a lot of movement, especially in research. We see still, like every year, so many new papers coming out, right? And they add a lot of different layers on top of Gaussian splatting, right? We see MLPs moving Gaussians in space or time. And this complexity makes it very tough to make or to define a new standard. But it is important because we see already also in the industry that Gaussian splatting is widely used. And so how can we better communicate? And this is something we really would like to drive forward together with the community to define a standard there that has to be, on the one hand, still flexible and extensible for future applications, but not too flexible that it is not really a standard anymore. So that, I think, balancing that is very tough and will be a good challenge in the future for us.
I also wanted to chat a bit about the support with Carla as well, and how that's been really like benefiting from NuRec.
Yeah, so lately we have now over 80 different scenarios reconstructed and provided to the Carla community. The research community can now use those reconstructions and create novel views, drive different routes there on those reconstructed scenes. And yeah, it's a first step towards really bringing all of this real world into Carla also right now. So we have done that now with ISAC Sim, but also with Carla, it enables another area of research to be then focusing again on making the roads safer and better for future driving.
Yeah, I have been looking forward to seeing like the results of all the simulation in the form of like autonomous vehicles, and I'm generally looking forward to just being able to hop into a car and have it take me to whatever the destination is. There's
a lot of good work ahead of us, right? There are very interesting advances using generative AI together with Radiance fields. I'm really looking forward to the research community contributing in that field, especially to enhance those novel views and make them even better. So, yeah. Yeah, papers like Gen 3C combined with like Cosmos and then like Diffix seem like a very nice trifecta to creating very large-scale novel view synthesis that still remains able to be reconstructed into 3D and then simulated. Yeah, maybe on top of that, we have Asset Harvester with NuRec, right? It enables us to harvest assets out of the real world and provide and build with that asset libraries. And there's a similar generative model in there that allows you to kind of infer the unseen views of those assets in the world. And that enhances, again, like novel views and allows you to composite different scenes in a novel way, and with that create new scenarios. So that's, for me, like, this is the key future for me, using generative models together with Radiance fields. Nice, thank you. Thank you for joining me today, and I really appreciate the conversation. Thanks for having me.